So in this video, we are going to continue building our development environment for web development. So in the previous video, we adapted Docker. So now we can run our project from a Docker container and communicate with the Postgres database also running in a Docker container. However, last time we had the problem that it was very cumbersome and error prone to work with because we had to provide all the configurations every time we run the project individually for each Docker container. And this is not a nice way to run the project. So in this video, we continue adapting Docker Compose, which will allow us to manage the whole project under a single file. So what we'll end up with at the end of this video is something like this. We'll have the Nginx reverse proxy communicating via a separate network called WebNet with our web application server, and the web application server will also be connected to another network for communicating with the DB service, that is the Postgres database. And we'll set up volumes to retain the data between restarting the Docker Compose file. So let's get started, and if you like these videos, please like and subscribe so I'll be encouraged to make more videos. So this is where we ended up last time, and we will continue building our Docker Compose file from here. So the topmost level we are going to have in our Docker Compose file is the services level, and the services are going to map to Docker containers running under Docker Compose. Not on a one-to-one basis, because a service might consist of more than one container, but we'll get into that in a later video. So the first thing we are going to need is the database service, and we are going to provide an image, and that will be a Docker image. So we'll use the Postgres latest image, and we are going to set up a few volumes. So the first volume we are going to need is the bind mount for reading our provisioning script. Because we are making a volume for storing the files, we're going to have to run the provisioning again. And our provisioning script is stored in a local directory called db files, and that will map to a directory in the root called db files. We also need a directory for storing our database. So we're going to call this guestbook db, and the left side of the colon here simply refers to a name, and that name we will need to declare in another section, as I will show you in a minute. But on the left side, when we do a bind mount, that refers to the local directory that we are running the project from. But here is this simply a name. So guestbookdb here is not going to be a directory in our project directory. It will be managed by Docker. On the right side of the colon, we again need to put the path that the Postgres database will put its data files into. So that will be var lib PostgreSQL, like that. We'll also need an environment file, and this is again because we need to set the environment, so the Postgres underscore variables that the database service will need for setting up the database when we start it. And we'll make that a little bit different from last time, because we'll actually need to be able to work with different environment files. And the way we're going to do that is by providing a variable at startup, and we are going to put that in double quotes here. So when we put it in double quote and use this dollar syntax, it will be substituted by the RTE variable at runtime. So if I say RTE equals dev for development, that will be the value that will be substituted here. So it will read env-dev. So that is a very nice way that we can control different behaviors in the Docker Compose file. We'll also connect to the DB network. So we call that dbnet, like that. So that will actually be our database service. Our app service also needs an image, and that will be our guestbook, latest, and we will also need access to the env file here, or rather we will have to have the env file set in our environment, and that is exactly the same here. We know that we need the two networks here, so that will both be dbnet and webnet. And we're almost done with our first iteration here. We need to declare the volumes, and that would be guestbook db. We're not going to configure it any further because the default settings is going to be just fine. So we'll just leave it like this, and the networks. Likewise, dbnet will just declare it here, and the same for the webnet. That will work with the default settings. So with that, we can continue configuring our reverse proxy. So we'll put that here, and we'll call it nginx, and the image we will use is going to be nginx latest, and we'll need a configuration file for the nginx service. So we'll make a volume section here for a bind mount, and we'll have a directory in our project directory called nginx, and on the inside of the Docker container that will be in etc nginx conf d, and we'll make that read only. There is really no reason why the nginx server should alter the configuration file, so we'll make that read only. Also here, read only on the db file. Again, there's no reason it should be altering the file. Actually, at some point we'll have to open the access here, because once we introduce the certificates, we will actually need to configure that, but we'll look into that later. We'll need some network connection here. So obviously our nginx should connect to the webnet to be able to communicate with the web application server. And finally, we are going to have two port mappings here, and that's because we want all the communication to go through nginx. So obviously there should be no direct communication with the database, no direct communication with the app service. So they will only be connected to these Docker networks, whereas the nginx reverse proxy here will need to have access to the outside world. So we'll put 127.0.0.1, and then we will put a variable here again. So that will be HTTP port. So we'll be able to run it on different ports depending on what we're doing at the moment. So we'll provide a default value here with this colon dash syntax. So what this means is that if the HTTP port variable is set, it will take that value. If it's not set, it will insert the value 80 in this case. And that just makes it easier to use. We don't have to provide the default value once it is declared like this. Right, so this will map the HTTP port, and we are going to need a similar mapping here. So we'll exchange this. So the HTTPS port here will be will be 443, and again there will be a default value of 443 if we don't set this HTTPS port variable. The next thing we need is going to be the configuration file that we are reading up here. So let's make the nginx directory in our project directory, and let's edit that file, and we'll call it guestbook.conf. The standard configuration that comes with nginx latest image is going to look for all files ending with .conf on this etc nginx confd path. So simply naming our simply naming our file something.conf will be enough for it to take effect. So guestbook.conf, like that. Sorry, I didn't save my changes, so just like this. Okay, so in our nginx configuration here, we will first declare an upstream, and we'll call that guestbook. So this is because this is not static content. This is going to be dynamic content provided by another service. So we'll list that here, server, and the name of the server will be app, and our app server is running on port 3000. So that will be enough for the upstream configuration. The smart thing about doing this kind of upstream configuration is that we will later be able to make multiple instances of the app server within the app service. And nginx will automatically do something called round robin. So it will send every other request to the two servers if there are two of them, and every third request to each server if there are three of them. So that will do automatic load balancing between them. The next thing we're going to do is to make a server section, and it's going to listen on port 80 to begin with only. And it will have a location called /, and that will simply forward everything to the guestbook upstream. So we'll use proxy pass to http://guestbook, and we'll end this section and end this section. So next we are going to have to make some adjustments to our environment file, and we will make a new environment file. So we'll call that env-dev. So this is this dev here is the value that we're going to use and be substituted by the RTE variable in our Docker Compose file. So let's just read the the env local file here because it will be quite identical to that one. So the first thing we are going to do here is that we are going to use the DB name rather than 127.0.0.1, and that is because now we are no longer directly connecting the service to the host network, and 127.0.0.1 will then be inside the Docker container and it will not be able to reach outside. So this is necessary for the configuration we have made now to work. It cannot work on localhost. So that's one thing, and the same thing is necessary for our web application server because it's going to also run with the localhost inside the Docker container. So we'll configure that to listen on all ports, so 0000, and this is because we don't actually know the IP address of this one. So it will work like this, and we'll just listen to all ports. So with that, we can actually go ahead and give it a try. And with that, we can go ahead and try to run our project. So first we need to set our environment variable here. And this is the variable that will be substituted inside the Docker Compose file. So we'll run RTE equals dev Docker Compose up and see what happens. It may or may not work, and we will see how it goes. So we don't have the Nginx image, so we're pulling that first. So let's see here. It looks okay, actually. So this time we started the Docker Compose up here in the foreground. So we'll have to leave that running and open another shell. So with that running, we can say RTE equals dev and then use Docker Compose. And we'll need to exec into the DB service, just like we did before, in order to run a shell and then run PSQL to run the provisioning script. So we'll specify the DB service and then the command that we are going to run. And with that, we have a terminal into the database server. We can run PSQL -u pg user and -d pgdb, and with that we have a prompt into the Postgres database, and like last time we can use the \i command to run the provisioning script. And again, we can also just check here DT to see that we actually have a schema that looks good, so we can quit out of this one and exit. With our database schema in place, we can try to use curl, and let me see here. So curl 127.0.0.1, and because we did not provide a port number for the Nginx service, it should be running on port 80. So issuing this command should not complain. And if we say curl -x post like this, we are going to send the message from last time to our Nginx server, and it works. So we can see that we are able to send the request through Nginx. The Nginx connects via the upstream to the web application server, and the web application server communicates with the database. So we can read and write to our database via HTTP requests. So that's all good. That seems to work fine. Now, I mentioned that this may or may not work when we started the Docker Compose up, and that might not seem very confident. And that is because at the moment we are relying on a timing of the various services to start up. And while that's fine, it's not always going to work. So let's make it a little bit more robust. And we'll do that by going into our Docker Compose file here. And we're going to introduce something called depends on. So depends on enables us to list a service. So this is the most the easiest way to address any potential timing problems. Simply listing services that are dependent on each other like this. And we will put here depends on. We'll list app here. And in most cases, this is fine. This is actually going to solve by far most timing problems, and we can see everything is still working. So this is the first level of trying to fix things. But if that is not enough, we can actually do some more here. So with our, so I'll just scroll up here so that you can see this is our DB service. And within our DB service, we can declare a section called health check. And within that, we can provide a test. And the test is going to be, first of all, make sure that you are using double quotes here and using this stand-in called CMD shell. Otherwise, it will not work. So you can't write SH here as we did in our entry point script. That will simply not work. So we'll have the shell here run a tool called PG is ready. And that is a tool that ships with this Postgres database image. And as you might have guessed, it will simply go and check if the database server is ready. So that's the first thing. We will set an interval. And that will be of 5 seconds. So every 5 seconds, it will go out and see if the server is ready. We'll also set a timeout. And that will also be 5 seconds. We will set a number of retries. So it will try 5 times to run the PG is healthy command. And every time it will accept a 5-second delay. And it will do this every 5 seconds. And then it obviously might run before the database is ready. So to avoid any starting issues, we will put a start period here of 30 seconds. Okay, so with that, we should be pretty sure that we now have a health check that that will determine if our database service is healthy. So far, so good. Now we need to make a change so that the app service will, rather than just depend on the DB service to start, it will now depend on it being ready with this health check here. And one of the things that might seem a little odd is now we're going to change this list entry into a label. And under that we will put condition, and that will be service healthy. So it will now be dependent on the database server not only being started, but actually being ready. And the last thing we are going to do is down here, because the Nginx service might also start up before the app service is ready. And we will put a restart unless stopped here. So if for some reason the Nginx server would break down, it is going to restart automatically, which is something that will make it a lot more robust. So we will write that change and try to restart our Docker Compose here. And you will notice now that it's going to delay a little bit, and that is because of our health check. And I will continue and we'll test again, and we'll see everything is still running. So with that, we have implemented Docker Compose, and we now have a quite robust environment for running this. So that all seems to work. So in the next video, we are going to set up a continuous delivery pipeline that will allow us to run tests and build the Docker image automatically whenever we push changes to the master branch. So that'll be in the next video. In the meantime, please like and subscribe, and maybe I'll make some more videos. See you later.